Hey guys, now I'm going to give you a quick walkthrough on the assignment that we have done for the course Deep Learning, which is basic neural networks using PyTorch, NumPy, and then TensorFlow. So first part is using NumPy. So this collab is all about to create a three-layer deep neural network using NumPy for nonlinear regression. First, we have installed all the necessary libraries required, such as NumPy, Matplotlib to create plots or plotting graphs, and then toolkits to create 3D plots. And then we proceeded to helper functions. So here we are generating a synthetic data for training. So creating 100 samples and then three with three features each, which is uniformly distributed between -1 and then 1. So it applies a complex nonlinear transformation using polynomial terms up to third degree, and it combines them with learned weights and biases. And then we proceeded with activation functions and their derivatives. So we defined ReLU function and TANH functions here, along with their derivatives, which are used as activation functions in the neural network. And then I proceeded with neural network class. Here we have defined a neural network class, initialized weights and biases randomly here. And then we also implemented the forward pass using TANH activation function between layers with a linear output activation. And this part computes backward propagation using chain rule to calculate gradients for weights and biases. And then we can update the weights and biases based on the gradients and our learning rate. Then we proceeded with training the model that we just created. So in this training the function, so we've initializes the neural network with specified input size, and then hidden size, and then output size. And then if you run this training section, it computes the forward pass to get predictions, and it also calculates the loss using mean squared error, and then it executes backward propagation to gradients. And simultaneously it updates the model weights and captures and print the loss after each epoch to monitor training progress. So training the neural network again, so it generates a test data set to evaluate the neural network. And then we proceeded with plotting the diagrams of the results. So this training loss plot shows how the loss decreases over training epochs, provided insights into the learning process. Here you can see the epochs here. And then we proceeded with the 4D plot. So this 4D plot displays the original data points and the predictions made by the neural network for the test data, highlighting how well the neural network was learned to model the underlying function. This is all about creating neural networks using NumPy. Let's proceed with part B, which is using PyTorch. So in this notebook, we demonstrated building a three-layer deep neural network using PyTorch, which is explicitly avoiding built-in layer functions to manually define components like weights, biases, and then activation functions. So we first proceeded with installing all the necessary libraries and imports like PyTorch, NumPy, and then Matplotlib. And then we proceeded with generating a synthetic data set in order to build the model and then train the model. This is all about data generation step. And then we proceeded with custom layer and model definition. So here we defined a custom linear class that mimics the functionality of a linear layer, initializing the weights and biases as we saw the previous step in NumPy. And then we introduced a custom ReLU model for a relay activation function. You can see here. And then custom model class comprising three linear layers and relay activations between them. So this model's forward method chains these layers and activations to process input data. Next, we proceeded with training the model in order to get the result, in order to compute the loss and then mean square error function. We defined a training function here to handle the training loop, which includes performing the forward pass to generate predictions, computing the loss, and then executing the backward pass, and then using SGD, which is gradient descent to update weights and biases. And then we proceeded with training the model using 10 epochs to monitor training progress. And then we proceeded with plotting the predictions using matplotlib visualization. So it generates predictions from the trained model without a gradient computation using PyTorch no grade constraint. And then we visualizes the original data and model predictions to compare the model's performance against the ground truth. That's all about part B using PyTorch. Let's move on to the part C, which is using PyTorch. But this time we've introduced classes-based three-layer deep neural network for non-linear regression using PyTorch, building functionality of modules. So in this Jupyter notebook, first we gone through the setup by installing all the necessary libraries and importing all the libraries like PyTorch, NumPy, Matplotlib, toolkits, etc. And then we proceeded with defining the neural network architecture. So here we defined a net class inheriting from NN module, which includes three layers. You can see the three layers here, two hidden layers and an output layer. And then we proceeded with generating the data for a non-linear regression task in three dimensions. So data transformation involves trigonometric functions and Gaussian noise. And then we proceeded with defining hyperparameters. So in this step, it specifies key parameters such as input size, hidden size, output size, number of epochs, learning rate. We define all the hyperparameters required to build a deep neural network using PyTorch built-in functions. And then we proceeded with initializing the model. So it creates an instance of a net class with specified architecture and hyperparameters. And then we proceeded with the training the model. So each epoch includes a forward pass to compute the model predictions, and then loss calculations using mean square error, a backward pass to compute gradients, an optimization step to update the model's weights using Adam optimizer. You can see, and then we proceeded with the next step, which is plotting the results. So here it switches the model to evaluation mode and generates predictions for the input data. Here you can see the visualizations. So it visualizes both the original data points and the predictions in a 3D plot to access the model performance. And let's move on to the next part, which is PyTorch Lightning version of the same. So using the PyTorch Lightning version, we are creating a deep neural network. In this notebook file, so here we implemented a three-layer deep neural network for nonlinear regression using PyTorch Lightning. So this library abstracts many of the details needed in typical PyTorch workflow, making the code more readable and simpler. So first we install all the necessary libraries like PyTorch, PyTorch Lightning, and then Matplotlib. And then we defined generate data function that creates a synthetic data using trigonometric functions and then logarithms to generate nonlinear relationships. This function converts the generated data into PyTorch tensors, preparing them for training. And then we proceeded with training the model by defining two PyTorch Lightning classes. You can see one is nonlinear regression, which is a class-based model that defines the neural network architecture, the forward pass for making predictions. And then the second one is synthetic data module. So this function manages data loading and batching using PyTorch data loader for efficient data handling and during training. It uses PyTorch Lightning's trainer class to handle the training loop, which simplifies the code and enhance readability. And then we proceeded with training the model, and then finally we plotted the results and visualized the both original data and then the predictions made by the trained model in 3D plot. You can see the visualizations of this model here. It's all about part D. And then we proceeded with creating the model using TensorFlow by various variants, low level API function, model, built in functions. In this notebook file, this illustrates how to build a deep neural network for nonlinear regression using TensorFlow in two distinct ways. One is a low level approach and using built in layers. First, we install all the necessary libraries like TensorFlow, NumPy, Matplotlib to handle the operations, data manipulation, and visualizations respectively. And then, after installing the necessary libraries, we proceeded with building the TensorFlow model using low level API. We first generated a synthetic data set here, which creates synthetic data where the relationship between inputs and outputs in nonlinear with the added Gaussian noise. And then we defined the model. Here we defined the model, a three-layer neural network using TensorFlow low-level APIs. And then we proceeded with the forward pass and activation, loss calculation, and then we trained the loop of the created model, and then we simply plotted the graphs. This is all about low-level API. Now we build the model using built-in layers. Like we did the same for low-level API. We first created a synthetic data, proceeded with the built-in layers here. Here we defined Keras sequential, which simplifies the model construction. And then we proceed with compiling the model, training the model. Finally, we have plotted the results in a graph using matplotlib. Again, it visualizes the original data against the model predictions. This is it about creating the deep neural network using TensorFlow by low-level API and then built-in functions. The final step is creating the model using JAX. So this notebook demonstrates building a deep neural network using JAX for three-dimensional nonlinear regression problem. So first, we've installed all the necessary libraries: JAX, NumPy, Matplotlib for data manipulation and visualization, and then helper functions. So we created various helper functions that we will need. One is equation function, neural network function, and then loss function, train step function. This function performs a single training step of neural network, and then we proceeded with plotting the results in 4D format. And then we proceeded with generating synthetic data set, and then we created the model using initializing the neural network parameters with zero values, setting up the stage for learning, and then we proceeded with training the model, which we have created from the synthetic data set. It executes a training loop that updates parameters using gradient descent, refined by the training step function over a specified number of epochs. Here we specified 1,000 epochs. So it run the model over 1,000 epochs. And then we proceeded with generating predictions on 3D grid, you can see. And then finally the plotting the data. So it will, again, it visualizes the both original function values and then predictions from the model in 3D plot, which we can easily understand the model accuracy visually. You can see the true and then predicted values here. That is all about the assignment. Thanks for listening. Thank you.